I want to take a few minutes now to look at an example of a situation where knowing a bit about logarithms helps us to solve a situation that's modeled off of an exponential function. So remember, when we have interest that's compounded continuously, it follows the formula A equals P times e to the RT power. This was continuously compounded interest. Now, suppose we want to know how much time it will take our money to double if we invest it. So, how much time to double our money? And I want to look at two examples. I want to look at what happens when we've got 3% interest, and I want to look at what happens when we have 6% interest. So if we want to double our money, what this means is that the amount we want to end up in the end is 2 times the principal that we started with. So this would mean we would have 2p equals p times e to the RT. Now, because both of these have p as a factor, we can divide both sides of the equation by p, and that actually eliminates it. We get 2 equals e to the RT. So now we want to figure out how much time it's going to take to double our money. So we want to solve for t. Now, right now, t is an exponent, and we've never had an equation where we tried to solve for a variable inside the exponent. But what we can do is we can rewrite this in logarithmic form, and that's going to end up making things easier to do. Remember, when we've got some sort of an exponent with a base, an exponent, and then the final result, we can rewrite this as a logarithm by writing log of the base, which in this case is e, of 2, that final answer, equals the exponent RT. Hopefully you're feeling a little bit comfortable with this, because we have a couple of times now rewritten things between exponential and logarithmic form. So now that we've done this, I'm just going to rewrite the left-hand side, because when we have a log base e, that's a natural logarithm. So we've got ln of 2 equals RT. And if we want to solve for t, we've got to divide both sides by r. And so if we want to calculate the amount of time it takes to double our investment, we just need to take ln of 2 and divide it by the interest rate. So let's do that for each of these interest rates. Let's look at 3% and 6%. If we have a 3% APR, then the time to double is going to be ln of 2 divided by 3%, which is 0.03 as a decimal, which we can use a calculator to see is approximately equal to 23.1. So it would take a little bit over 23 years to double our money in that case. Let's look at 6%. Here we've got t equals ln of 2 over 0.06, and this is approximately 11.6 years. These are both in years. So if we found a 6% interest rate, we could double our money in only 11.6 years. So this is a way that we can use logarithms to learn more about situations that are modeled off of exponential functions. We're going to be seeing more of these situations as we move forward in our exploration of exponential functions and logarithmic functions.